All right. Well, good morning. So I will give you today just a quick introduction on Halliburton and where we kind of fit into the energy transition, and specifically on a geothermal project we have been involved in Norway so far. And it's really about, for us, we as a well-serviced company, we are focusing on the execution of the projects mainly. When it comes to the decarbonization of the society in general, we have three different levels that we're working on. We are working on with ourselves, what we call our sustainable core, being what can we do within our company and our operations in order to reduce carbon emissions and kind of become a more environmentally friendly operation. And in those initiatives, we also help our customers to develop, while we're developing solutions for the traditional oil and gas and also the renewable industries that has less impact on the environment. So that is kind of the core of it all. It starts with the sustainability agenda and the energy transition. And then as a result of that, there are new markets coming out, what we have called our low-carbon solutions. That's basically focusing on the new markets that are coming out, where we can deploy our core competencies and capacities, in that industry and add value, basically to drive them forward. So it's focusing on carbon capture, geothermal, hydrogen, and hydrogen storage, and methane abatement is probably not very big in Norway. We kind of dealt with that in our offshore industry a long time ago, but globally it's a big issue. Lots of methane still being exposed to the atmosphere. And also, all of this is related to originally, historically, oil and gas, now getting into the more environmentally friendly solutions. But also, we are looking into more electron-based, a future where, and we organize that through our Halliburton Labs. Is a company run by Halliburton, which is basically an incubator or a startup facilitator. We help startup companies to kind of commercialize their products and get them out into the market. So we are using our infrastructure globally to help these startup companies deploying new technologies in we call it our Tesla department, really. It's really where we are looking at, outside traditional oil and gas and the other areas. So speaking about geothermal, Halliburton has been involved in, for the last 40 years in geothermal projects. To date, more than 365 wells, more than 500,000 meters drilled, and 120,000 operating hours. So it's an area where we are familiar and we understand the challenges associated with geothermal drilling. Now, we focus on what we would call deep geothermal, where our oil and gas technologies are a natural kind of, value-adding capacity. So the more shallow projects, we do not tend to get as much involved with. And also the range of, as geothermal can be very technically fairly simple systems to more complex and more advanced and more extreme conditions. And we kind of cover the whole range there in terms of where we get engaged. So what's our focus on geothermal? It's really about getting long-term economical production out of the project, right? So how do you get that? Well, first of all, you need a heat source, and that needs to be assessed, so you know that the heat is there and that you will get the effect out of it as you need. It's about reservoir characteristics. Is it a producing asset, or is it heat transfer, exchange kind of concepts? Drilling efficiency is very important when it comes to the execution, because these projects are usually marginal projects with a long payback time. So, being efficient in the operations and the execution of the job, where your cost is related to days and time, is very important. The well integrity part, the technical part, that the well will actually, and the operation and the well will actually do what it's supposed to do and actually last for those 20, 30, 40 years is also very important parts. And of course, through the production phase, how to keep the operations and the production steady, not having to go back and reinvest or fix things that are appearing. So these are the main challenges that we see related to getting a long-term economical project. So, and our core business, to be frank, is really about the reservoir characteristics, the drilling, and the well integrity. This is where, we see that our core competency is. Of course, we are well aware of these as well, but this is where we see that we can actually add most value to these projects, right? Value drivers for our customers or for the project owners. It's really about subsurface, the insight, understanding what's happening and what's the conditions underground. It's how to get as much heat out or how much effect out of the project as possible. It's very important, the risk mitigation strategies you put up, understanding the risks, the technical, operational and economical risks. It's important to have a clear idea on that. And of course, the integrity of the system you're putting in, that it will last. Those are the main value drivers we see from our customers. A little bit more detail. I guess it's probably mentioned most of this, but as you go through the different phases of the project, you see that we get in early on the subsurface part. We are heavily involved in the wells construction, completions, and also in the production phase. And then there's a little space here where we don't tend to get as much involved. That's really about the plants and the surface and the that part. We do not focus on that at the time being. So it's more about the subsurface drilling and getting the wells in place. So just an example from Norway where you can see a direct transfer of oil and gas technology into the geothermal business is the Kvitebjørn Varme project. It was presented last year on this conference in Bergen by Ruden, by Eivind, who was the project leader for that. As you may remember, this is a heat storage, seasonal storage project, basically where Kvitebjørn, the Kvitebjørn Varme is the local, they burn the waste from the Tromsø municipality, and they're distributing the heat from that on the central heating system in Tromsø. So they kind of own and operate that system. And then the challenge up there is, of course, in the summertime they have excess heat, and in the wintertime they don't have enough heat to feed the network. So that's how Ruden actually started up a project and developed a concept around this. And actually they won a prize on ONS in 22 based on the concept for innovation. That was specifically an innovation award for transferring technology from oil and gas to new energy markets. And that is based on the concept here is basically based on the fact that you drill or an injection well in the center, and you drill wells around, and you kind of create, like we call it, a thermos. And then you open up fractures in between the wells to kind of get this surface area where you can, when you circulate the hot water in the center, it will go through the fractures and come back out in the circumferencing wells, and you charge up the formation with heat. And then you reverse that when you extract heat. You reverse the flow and you take the heat back out. So we were planning to drill 11 wells. I think we ended up with 1 injector and 9 producers. And then where we came into the picture is really on the fracturing side, when you open up and to do that engineering and actually execute it as planned is key, because you want to keep the fractures within your thermos. You don't want leakage, so you don't want the fractures to move far away from your site. So being accurate in the engineering and in the execution is key for that to happen. And it's based on the Halliburton Surgifrac method, which is oil and gas fracturing technology. adapted to this new application. We ended up doing some 32 jobs, I believe, and basically just pumping standard water, no chemicals downhole. So it's a clean, environmentally sound process. This is from the site where here's the injection well where we do the frac jobs, and we have the equipment lined up around here. So that was March last year. Another picture from the site and some data from the project. 88 tons of sand we pumped downhole and placed at 35 jobs. This is basically measuring the this is measuring the injectivity in those 35 jobs, and as you can see, you have some higher flow on low and bottom, and a little bit tighter in the center. So that's one of the challenges you have with these things, is to try to get this as even as possible, because you want to distribute your water flow right as you're circulating. So that is something that is a key objective, is to try to get this as steady as possible for the jobs. So, but the result is that there is good communication. There is very little leakage. 97% of the fluid that is pumped into the system is retrieved through the return wells. So that indicates that there is, we have been, it's been a good kind of execution on keeping the water or the heat within the thermos. And we also will go. You see again, distribution of flow is a little bit up and down. So we're considering maybe go back and do a little bit more of stimulation here in the center to kind of even it out. That's what they're calculating on. Last year, they started test production and kind of heating up the formation. We got 2.5-3 months of heating up before the winter came, and all the heat goes to the city. So the plan is to start up again in April this year, and the ambition for April for 24 season is to charge up with about 10 gigawatt hours, and then the second year they are planning or trying to achieve 20 gigawatt hours of storage kind of capacity. So it takes a couple of years actually to charge up this reservoir before you can start extracting. So I think that's it. Thank you.
Walter, this diagram on the upper left, showing the wells and red line, which I suppose are fractures or pathways.
It's an illustration, yes.
Yes, okay.
Yeah.
So have some work to do,
maybe yes. So this is Eivind should be able to explain in detail how he has come up with this, but there is a process behind it. But from my understanding, it's an illustration. It might be affected on where some of the data we saw from the jobs, but there is not, it is an element of art in it. I think that is fair to say.
My point is that by improving our knowledge there for these stimulation jobs, we can better understand the thermal storage and the efficiency of different, you could think of it like an oil reservoir.
Yep.
Compartmentalized. And we don't want to waste money in dead compartments.
Exactly.
Yeah.
Yeah. Oh, and that is, I guess, one of the main challenges with this approach as well. Is how to do actually, the rock is not homogeneous, and there's always a risk, a technical risk in, but it's all about understanding the information and the work you do up front in terms of understanding the mechanical properties of the rock that you are going to work with. That's key, in achieving that.
So could you please comment on the business case? How many operative years do you need in order to pay down the upfront capex? I mean, 10 wells to 300 meter fracturing job. And then operations.
So here I come in as a contractor. Actually, we got paid.
Sure.
So the big numbers on the project and the payback time, I cannot say, but I would think it's between 10 and 15 years.
Yeah. You generate 20 gigawatt hours. That's 1 kroner per kilowatt hour is 20 million kroner or 2 million euro as the value created each year. And for 2 million euro, not too many years, you can do quite a lot of drilling to 300 meter. So the drilling in this case especially is not a big... I'm just making up, if we multiply by 1,000 kroner per meter and we do that kind of calculations.
So no, as we do not have insight in that, in that information, because the drilling, this was a project run by Ruden, and they were the project manager for it, so they know exactly the different elements and what they cost. But the drilling was done on air. It's air drilling by Bosum, done in 22, and then the wells are about 300 meters deep. So
we have a question by Malte up there.
After years of running, what will be the surface temperature? You don't know.
Sorry, can't help you. Can find out. We will talk to Evan about it. He will. They've done a lot of studies on that, on what will happen in the long run as well. There was also due to well, this word right here tends to get attention because there are some, let's say, not good experiences with fracking, on land elsewhere in the world. So there was a lot of concern about micro seismic activities and stuff like that around this, and that was actually measured also during the project, and there was no activity registered as a linked to the project. So that's.
We don't know what future brings, but they are considering putting a CO2 storage facility here on top of this or nearby. So thermal expansion is being evaluated. To what extent do you have a ground heave during cooling and heating? And this is something we work with.
Yes.
And it's also a fantastic project.
And we see that from other places where they have the same issue where they could use seasonal storage. Now also these plants are now being equipped with CCS units, and of course that will take away some of the heat from that available heat for storage. So some of these projects are now being pushed out a little bit because we need to understand how much heat do we actually have available once the CO2 capturing part is in place. So
exactly.
Yeah.
Thanks again.